Okay, ladies and gentlemen, let's go ahead and start taking a look at geometry. Now, we've already talked about how you have Euclidean and non-Euclidean geometry. The big thing is that we're going to be working this year with Euclidean geometry, also known as plane geometry. The reason is because Euclidean geometry is only focused on working on a flat surface. Now, if you think about the history that we already know about this, it does make sense that if you were looking from Euclid's perspective well long ago, you would not be thinking in terms of things on a circle or a globe. You would be thinking of things in terms of flat planes, because most people's view of their world is limited to what's around them, or at most what they can see from a high hill. So although obviously mountains and different landforms existed, everything was assumed to be basically flat. And so as long as it is flat, then Euclidean geometry holds up very, very well. All 5 postulates. Now let's talk about those 5 postulates. So, number 1, through any 2 points, you can draw exactly one line segment. Postulate 2, if you take that line segment and extend it infinitely in each direction, you have a full line. Okay, that's number 1 and number 2, all having to do with segments. Let's add another one. Number 3 is if I take that line segment and I use one endpoint as the center of a circle, I can use that segment to draw an entire circle. So a circle would be a set of points equidistant from this one point. That's postulate 3. Okay, let's look at the 4th postulate. The 4th postulate states that all right angles are congruent. Now, right angles, what are right angles? Well, right angles are angles that are exactly 90 degrees. So all 90-degree angles are congruent. That's what postulate number 4 says. Now that's really important, because if I have 2 intersecting lines, one like this and one like this, if it makes a right angle here, then from just that simple setup, we actually get a ton of actual other theorems and different ideas that come out of this. Because if one of these is 90, all of a sudden you figure out others may be 90, and if all 90-degree angles are congruent, then I have a whole bunch of congruent angles, and it's actually the basis for our modern built world. Now, those are the first 4, and those work really, really well. What we have to worry about now is postulate number 5. So let's talk about this one. You've already seen it in your history video, but let's take a look. So if I have any 2 lines, and if I have a third line that cuts those 2 lines, if the angle between these 2 lines is less than 180, eventually these 2 lines will cross. Now, the alternative to that is, if I have these 2 lines and the interior angle is not less than 180, it's equal to 180, then those 2 lines will never cross. But that's not actually the postulate. A postulate is an assumption that's being made. His assumption was for angles less than 180. But what we can do is we can take a postulate, we can build on that postulate and create a theorem. A theorem is something that can be proved or follows logically from a postulate or axiom. So, with his basic assumptions, we can now begin building more theorems. And it's the building of those theorems, one on top of the other, that creates the system of geometry that we have today. That's why we're going to confine ourselves to Euclid and his plane geometry, rather than the non-Euclidean stuff. But that's just the 5 postulates. What we need to do now is we need to say, well, how do you make these points, and what are these segments of which you speak? Because you see, all of these axioms or assumptions are still based on something even more basic. The thing that's even more basic is the fact that you have 3 basic elements really composed of exactly one basic element, the point. If I have a point in space, and in particular in non-Euclidean geometry, a point on a flat surface, you have this point. If I string a number of points together, I now get this line segment. And you'll notice already in that first postulate, between any 2 points is a straight line, you have two basic components: points and a line segment. And the line segment is nothing but like a string of pearls or Mardi Gras beads that are points tied in together. Now, the next thing that you have is you go from a point to a line, and now we need a plane. Well, think about this. Whether it's a weaver sitting and weaving fabric by sending that line back and forth and stacking line upon line upon line, or whether you think about it as flooring or wooden planks on a floor. Here's a board, put a board next to it, 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 and you have these lines that create a large expanse. That's a plane. The best example of the planes that we have are look out in the fields, because obviously we're planting row upon row upon row of crop, and each one of those rows is actually a single plant. They're not like a vineyard where they grow in a line. They're each single plants, but you put enough of those single plants in a row and put multiple rows together, you have a sea of green. And that's the key thing to a plane, is that that plane goes on and on forever in every direction. It is infinite. So using, for example, a piece of paper is not a great example of a plane, because that piece of paper at some point has an end point. It goes off the plane. But that doesn't make sense in Euclidean geometry. Just like a line can go on forever each way, a plane can go on forever in every direction. So we have two-dimensional space. Now eventually, what happens if we take planes and we put multiple planes together in different fashions? We now get into three-dimensional space. So with that, that's the basics, the 5 postulates and the 3 basic components, point, line, plane, to geometry. Out of that, we're going to build basically everything. Now, one other thing that we're going to need to talk about is how he actually physically built geometry. And to physically build geometry, he had exactly 2 things. He had a compass and he had a ruler. Now, not a compass like that you find north, south, east, west, okay? A compass is simply an angle that has a fixed point at one end and a marking point at the other end. And using that compass and a straight edge, you can create all of the geometric shapes built from points, lines, planes, etc. And we're going to get into that as well. So, using very basic tools, something that even that straight edge is not marked off in sizes, and you'll see why not in a little bit, we can create all of Euclidean geometry. So that's why this is the class that you're taking, because it literally builds everything from the ground up. And additionally, we also are training you from the fact that there's just 3 basic things, point, lines, planes, or 5 basic assumptions, that you can actually build an entire system of geometry that covers everything from perimeter to volume to relationships to how pieces interact with one another. You're starting with very basic pieces. With that in mind, let's get started with this class in geometry.